Hi everyone, this is David speaking, and today's class we will talk about the trend component of the time series and how to compute the parameters associated with this trend component. Okay, let's go back to the set of data of the energy consumption in Brazil in the last 20 years. Here we have the energy consumption in the last 20 years from 1997 and 2016. So the objective of this class is to try to obtain, this is the set of data, and we want to obtain this line, which is the best line to approximate with the set of data related with the energy consumption. And basically, to obtain this line, we need the intercept and the slope. And for this class, we will compute both parameters, and to do that we will use the least square method, and the parameters will be obtained as follows. We want to minimize a function, and this function is the sum of the square error between the model and the actual data. And why do we need to use the square? Because it doesn't matter for us if the error is positive or negative. We want to minimize it. So this is an interesting function to achieve this objective. So here we have the sum from 1 to n, where n is the number of the data that we have. Y is the set of original data, and Y with this part is the model. Then we have the model associated to both parameters in a linear equation, which is beta 0 plus beta 1 multiplied by x. Okay, this is the model that we want to obtain. So we minimize the difference between the actual data and our model. And to do that, we need to compute the derivative of this function with respect to both parameters, beta 0 and beta 1. Let's start with beta 0, and after the computation of this derivative, we need to make it equal to 0. In this way, for a quadratic function like this, when we compute this derivative and make it equal to 0, we guarantee that we are in this point, and then we have the value associated with the minimum value associated with this function. Okay, so first of all, we need to start by computing the derivative of this function with respect to beta 0, and this is 2 multiplied by this function, and we need to compute this function beta 0 with respect to beta 0, which is minus 1. Okay, so to develop this function, we need to know that when we multiply a number for a function and it needs to be equal to 0, it means that the function should be equal to 0. So developing this expression, we have the sum from I equal to 1, from 1 to n, yi equal to, I will put it in this side of this expression. Then we have n multiplied by beta 0, because we need to sum from 1 to n, plus beta 1 multiplied by the sum from I equal to 1, from 1 to n of xi. Okay, isolating beta 0, we have this expression, which is the average of the set of the data, minus beta 1, the average of the set of the explanatory variable, which is the time in our application. Then we have the a simpler way to write it. Okay, so now we need to compute the derivative of the function with respect to beta 1 and make it equal to 0. We have 2 multiplied by this function, and the derivative of this function with respect to beta 1 is minus xi. So developing this expression, we must consider that this expression should be equal to 0, and then we have xi multiplied by yi plus xi multiplied by beta 0 plus beta 1 multiplied by the square of xi, and it should be equal to 0. Replacing the beta 0 value that we computed in the last slide, replacing it here, we have this expression. And now we are going to work in order to isolate beta 1 and obtain the second parameter of the model. So developing it, here we put this expression in this side. So we have here xi multiplied by yi, and the sum from I equal to 1 of 1 to n, and then we can put it in this side of the sum, because it doesn't depend of the value of I, and then we have xi, the sum from 1 to n of xi, plus beta 1, the sum from 1 to n of xi squared. So continuing developing this, we achieve these results for beta 1. Now we have the beta 1 value, and we can put it here and obtain the beta 0. And we have the 2 parameters, and we can obtain the model by these 2 parameters. Okay, in the next class I will put it on Excel, and then we can compute each parameter and show graphically how it fits in our set of data. Okay.